Alright, for today's math notes, we are going to do least common multiple. Hopefully this is also a review, like greatest common factor. I'm going to show you some cool things to do with least common multiple, actually with the ladder method, to see if it makes sense to you. Again, I'm going to show you the 3 different methods to solve least common multiple, and again, I'll use the ladder method because it has so many great other qualities involved in it, and I'll show you. I'll give you an example of a couple. So we're going to start off with a vocabulary term. Multiples, unlike factors, factors are smaller. So in order to remember what factors are, I think of a number, let's say 60 and 40. Factors are going to be smaller than the number, or equal to. Multiples are always equal to or larger. So, multiples are the sequence or pattern of numbers. And just the way that you learned it in your early days, it's like skip counting. It's counting by that number. 3, 6, 9, 12, 15, 5, 10. 15, 20, 25, okay? 60, 120, 180, 240. So skip counting is multiples. So I'll show you, do an example of 5. And I'm going to write down what I just said. Multiples are always greater than or equal to the number you start with. Whereas factors are smaller, because I know students always get multiples and factors confused. I teach this all the time and I still get multiples and factors confused. So the factors are equal to or smaller, multiples are equal to or greater than. Okay. Least common multiple stands for lesser, which is a word. I know it sounds weird, but it is proper grammar. Lesser, or the smallest. Same, when you're comparing 2 or more numbers. Multiple is a pattern number, or a skip counting number, or a sequence number. Okay? So the 3 ways to solve list, which can take a really long time if your numbers are big. Ladder, tree. And the tree is the most confusing. I told you that already. Most confusing for me, but really when it comes to multiples as well. Also, before we continue, you might want to pause. I am going to use a highlighter. Okay, so our example problem is find the LCM of 8 and 12. Find the LCM, or least common multiple, of 8 and 12. We know that our answer is going to be greater than 8, greater than 12, or equal to 12 is the highest number, or the largest of the two. So it's either going to be greater than 12 or larger than 12. Okay, you can make a list. 8, 16, 24, 36, 48. Oops, I forgot 40. Oh wait, I'm not counting by 8s, I'm counting by something else. Sorry. 8, 16, 24, 32, there we go, 40, 48, 56, 64, 72, 80. And if we don't find it, then we have to keep going. 12, 24, 36, 48, 60, 72, 84, 96. So you can probably see that I have common multiple here and common multiple here. I have two common ones that I wrote down, but I'm looking for the lesser. So the LCM of 8 and 12 is, you guys, I'm sorry, I'm having trouble writing, 24. This says LCM of 8, 12 is 24. Okay, so there's our list method. Here's our ladder method. And I'm going to come back to the ladder when we have, there's a trick, definitely, that we need to know for this ladder method with LCM. And I'm going to come back to it because this example problem doesn't have it. So what goes both into 8 and 12? I'm going to say 2. 2 goes into 8 4 times. 2 goes into 12 6 times. Again, you can break both of these down. 2 and 3. Now, once I have the smallest that I can go without breaking these down anymore, I'm going to multiply the L for least common multiple. So if, as you can see, L for least common multiple, I have to multiply 2 times 2 times 2 times 3. And that's going to tell me what the least common multiple is. So 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. Alright, tree method. 12 and 8. So 12 is 2 and 6. 6 is 2 and 3. 8 is 2 and 4. 4 is 2 and 2. So then what I have to do is I have to write them out. 2 times 2 times 3 and 2 times 2 times 2. Then what I have to do is I have to take the ones that are, I'm going to circle the ones that are the same. So I'm going to put these, I'm going to take this tree, this one over here, and I'm going to put it under here so you can see it a little bit better. Oops, 2 times 2 times 2. Okay. So this is the same, and this is the same. And when I have them that are 2 and 2, they cancel each other out. And it only makes 1 2. So 2 times 2. And then these two don't match. So they're independent. So they go down here. And so you can see I have 2 times 2 times 3 times 2, just like I had it over here. So 2 times 2 is 4, 4 times 3 is 12, 12 times 2 is 24. And like I said, the tree method is where I get really confused, because you have to line up those ones that are the same and then remove the ones that are different and put them down here. You don't remove them, you just put them into the equation. It's this one is difficult for me to explain even, because I don't really understand how it works, but I don't want to take it away from you if this makes sense to you. Okay, so we're going to do some example problems. And the first one we are going to do is find the LCM of eight and 10. We just did 8 and 12. So 2 goes into both 8 and 10, 4 and 5. Now, here is the thing about, nope, actually there's no prime number that goes into both of those. So we're done. We make our L. We multiply 2 times 4 times 5. 2 times 4 is 8. 8 times 5 is 40. So the LCM of 8 and 10 is 40. All right, let's do a little bit larger number. We'll do 30. That one's prime. We won't do that one, it's prime. We'll do 49 and 63. Remember, LCM, not the factor, because I look at this and automatically think, oh, these two have 7 in common. 7's the least common multiple, but no, that won't work. It has to be larger. It's a multiple. But since I do know that 7 goes into both of these numbers, I'm going to go ahead and use it. 7 into 49 is 7. 7 into 63 is 9. And because 7 is prime, I know that there isn't anything that goes into both of these. So I'm done, and I'm going to do 7 times 7 times 9. I know 7 times 7 is 49, and 49 times 9 is... I'm going to let you work on that math before I give you the answer. I can't give you guys all the answers. All right, hopefully you've got it. Check your answer. You should have gotten 441. So again, this is a big number. It's larger than what we started with. And since we already started with large numbers, we knew we had to go larger. Okay, now I'm going to give you an example using three numbers. So we're going to find the greatest common multiple of... my book just fell. Sorry, least common multiple of 6, 9, and let's go with 14. Okay, so here's the tricky part. You want to find a common multiple that goes into at least 2 of these. At least 2. Sorry, factor, not multiple. Common factor for at least 2. When I have 3 numbers. So what I'm going to start with is 6 and 9. I know that 6 and 9 can be divided by 3. So I'm going to divide by 3, and I'm going to do 3 into 6 is 2, and 3 into 9 is 3. And I'm going to move my 14 down because I didn't do anything with it. Okay, now what I'm going to do is I'm going to look for a common factor that goes into, again, at least 2 of these, and I see that 2 goes into 2. It doesn't go into 3, so I move the 3 down, and it goes into 14 7 times. Is there a number that goes into 1, 3, and 7? No, these are all prime. So I can't go any further. So this is my L. And I do 3 times 2 times, I could put 1 in there, but anything times 1 is itself, times 3 times 7. So 3 times 2 is 6 times 3 times 7. To make the math easier on myself, I'm going to do 6 times 7, which is 42 times 3. And now I can solve for the least common multiple. And I'll give you a minute to do the math, and then I'll give you the answer. you should have gotten 126. So the LCM, least common multiple of 6, 9, and 14 is 126. All right. That, I told you that was a little confusing because we had to find at least 2 numbers that went in and then we had to move it down. That moving down is the part that we forget. If it can't go into it, we move it down until there's nothing that goes into at least 2 of these. And then we find our L. Okay, I'm going to give you 2 to-dos. And we'll check tomorrow morning. They're both find the LCM. The first one is going to be $18 and $45. We didn't do that yet, no? $18 and $45. Oops, sorry, you can't see it. And then the second one will be $15, $25, I'll just keep you with 2 for now. 15 and 25, 18 and 45. Use the method that best works for you. This one with the moving things down, I think it's also called the slide, is a little bit confusing, I understand, but we'll practice it more until you get it. Alright, don't forget, we'll check it tomorrow in our morning meeting.